Section 3 talks about rate of change and slope. So it definitely sounds like we've talked about slope before in 7th grade, and all of chapter 3 and 4 is related to slope. Slope definition, mathematical definition, is the ratio of the change in the y coordinates to the change in the x coordinates. So in a line there's all these coordinate points, and so that means there's change, okay? So there's an example that's done for you here. One thing to note is that the greater the absolute value of the slope, the steeper the line. So meaning if you have slope that is a positive 2 versus a positive 1/4, the slope with the 2 will be a steeper line. So if we scroll down a little bit, we can kind of get to how to find a slope when we have two coordinate points. So the slope of a non-vertical line, meaning it's diagonal or something, is what we might be familiar with is the rise over the run. And the rise means the up and down, and the run means the left and right. And so you can find that with this formula, y2 minus y1 over x2 minus x1. And so those are just your coordinate points. This note right here, the slope of a line, it can either be positive, negative, 0, or undefined. We'll get to that on the next page. Let's go down to the examples. The directions say, find the slope of the line that passes through the pairs of points. So there are 2 points here, negative 3, 4, and 2, negative 3. And so if you connect these points, what would be the slope? And so we're going to use our formula m, which is referred to slope, is y2 minus y1 over x2 minus x1. And so we have 2 coordinate points, right? And so both of these coordinate points are x comma y. Now since there are 2 coordinate points, we refer to one of these coordinate points as like the first one, right? So if we call this one the first one and this one the second one, and so that's where we get the x2 and the y2 and all that stuff. And so you just plug these numbers in. So for y2 you get negative 3 minus y1 you get 4 over x2 is 2 and x1 is minus, x1 is negative 3. So make sure it is always going to be minus. Even if you do have a minus negative, that will eventually change. And then we just evaluate it. Negative 3 minus 4 turns out to be negative 7. 2 minus negative 3 is actually 2 plus positive 3, which is 5. And then if it's possible, simplify it, but leave in an improper fraction. Negative 7 over 5, that is my slope. So what this means is that you go down 7 and to the right 5. Okay, so that's what you would do for the slope. Go ahead and try numbers 2 and 3 to find what the slope would be there. If you got this as your setup, negative 1 minus negative 1, that minus negative in the middle will change to a plus positive. And so negative 1 plus 1 actually gives you 0, so 0 over negative 1. Now this is not simplified, 0 over negative 1. Because when you have a 0 in the denominator, or I'm sorry, in the numerator, your slope is 0. M is 0. Okay? Now, number 3, go ahead and try that one. So your setup could be negative 3 minus 4 over negative 2 minus negative 2. But again, this minus negative changes to a positive. So in the numerator, you could have negative 7 over 0. Now, this is not equal to 0. There is a mathematical rule where if you have a 0 in the denominator, it is actually something that's undefined. So undefined. Now, if you think about these points, okay, let's go back to number 2. Think about what a graph might look like here for number 2. So let's say I have this graph. And for number 2, if I plotted 3, negative 1, and 2, negative 1, those would be my points. And then if I connected these points with a line, What kind of line is that? It's a horizontal line. So whenever a slope is 0, that means there's a horizontal line happening on the graph. Now what about number 3? What would that look like? In number 3, the coordinate points that they ask for is -2, 4. That's up here, and -2, -3. That's down here. And so if you connect these points, you'll notice we have a vertical line. So an undefined slope is a vertical line. So if you actually think about connected from chapter 1, this would not pass the vertical line test. So this is not a function. I think that's why it's referred to as undefined. So those are the examples for how you can find the slope between two coordinate points. Let's scroll down and we'll kind of talk about the different types of slopes. So you can have 4 options. A positive slope, so from left to right it goes up. A negative slope, from left to right it goes down. A 0 slope, you'll again notice that it's a horizontal line, and an undefined slope, which is a vertical line. So this is actually very important. So if you, let's say, see a graph and you get m is equal to -5, but the graph is a positive slope, then that must mean that you had some kind of miscalculation with that -5. Okay, so that's a pretty good indicator. Let's scroll down a little bit to example 4. Now that we know how to find the slope when we are given 2 points, this question is asking, find the value of r when the slope is 1/3. Try to think about how could you find this missing piece right over here when you know the answer of the slope. Try to think about, pause the video, set up an equation of how you can figure that out. We know this formula. So I'm just going to plug in all the things that I know. So do I know my m? I do know my m. I know that it's 1/3. Do I know y2? My y2 is actually this missing piece right there. So I could do r minus, do I know my y1? -4 over x2, which is -5, minus 1. And so this is what I have. It's not really a great equation, but something what we know from previous chapters is when we're trying to solve for a variable, we can cross multiply. And so when you cross multiply, you get on one side 1 times, -5 minus 1 is actually -6. Okay, so 1 times -6. And on the other side, you have 3 times r minus 4. Take a moment to evaluate that. So after I evaluated it, I distributed, added 12 on both sides, divided by 3 on both sides. I got r is equal to 2. So my missing number is equal to 2. If you want to check that, you can. You could go back and just plug in 2 minus 4 over -5 minus 1, and that gives me -2 over -6, which reduces down to 1/3. So that check works. Now the rate of change it's the same thing as a slope. Okay, it's a ratio that describes an average. How much one quantity changes with respect to a change in another quantity. It's the same thing, right? How much the y changes with respect to the x. Let's scroll down a little bit and take a look at example 5. Example 5 says, use the table on the right to find the rate of change, then explain its meaning. So if you look here, it says the number of computer games is my x, and the total cost in dollars is y. Even though they give you 3 pairs of numbers, which is like 3 ordered pairs, you only need 2. So it doesn't matter which one you pick. I'm just going to choose these 2, okay, just because. And so you do the same thing. You use that equation and just plug it in. So I'm just going to have, I can have 78 minus 234 over, since I started with 78, I gotta start with the 2, minus 6, and calculate that, and I believe I get, let's see, 6, 5, 1, negative 156, over negative 4, and you clearly have to simplify that to get 39. Now it says find the rate of change, it's 39. But since it's kind of a story, they're asking then explain its meaning. So what does this 39 mean with the table? The 39 means, this is really 39 over 1. And in the numerator is the y values and the denominator is the x values. So this means it's $39 per computer game. And so that's how we apply slope with tables and graphs. Let's move on to example 6. Example 6 shows a graph. Now, if you look at the right on the graph, it's clearly not a straight line, but there are parts of it that are straight. So you'll see here in part A, it says find the rates of change for 2000 to 2002. So that's actually referring to this part right here. And 2002 to 2004. So that is referring to that part there. So they're asking for those different rates of change. So let me help you with the 2000 to 2002. So my slope m is equal to, my y value going up and down is 324 minus 317. I just need to find the difference between those two. And the difference between the years is 2 years, right? 2002 to 2000. And so the number of, I believe this is people, right? The number of millions of people, 324 minus 317. The difference there is 7 over 2. So the rate of change is 7 over 2 for the years 2000 and 2002. Go ahead, find the rate of change for 2002 and 2004. There is my rate of change between 2002 and 2004. Letter B says the same thing. Explain the meaning of the rate of change in each case. So in our green case, which represented the years 2002 to 2002, 7 over 2 is 3.5. So meaning it increased 3.5 million people per year. And try to think about what is the meaning of this 1/2 between 2002 and 2004. That means that only 0.5 million more people per year. So there's an increase, right? For letter C, it says, how are the different rates of change shown on the graph? So if you actually notice, 3.5 million people per year. If you remember in the beginning of these notes, it said the higher the number, the steeper the slope. So if you notice here, since I have it in green, this one is steeper than my purple slope, right? It's steeper. So there's a connection between the numbers and the graphs. Let's move on to the final examples. Question here says, determine whether each function is linear. Explain. And all we're given is a table. So take a look at that. And I want you to pause the video for a sec, kind of mess around with the table here, and I want you to make a conjecture. Do you think it's linear or not? And give an explanation why. Well, let's see. So the difference, if you see the difference here, it is going down by 2 each time, right? Negative 6 minus 2 gives you negative 8. But my x's are going up by 3 each time. And so so I don't know, would you say this is linear? Let's kind of hold back there. Let's look at B. Letter B, it's going up by 2 each. It's going up by 2 here, and then plus 4 here, and plus 2 here, and plus 4 here. And then my x's, it's going up by plus 2, plus 2. So my x's look consistent. Which of these do you feel like is linear? A function that is linear has a consistent pattern. So it has a consistent slope. This slope here, if we're doing y over x, the slope is -2 over +3. But here there's not a consistent slope because right here there's a different slope. It's 2 over 2, but at a different point in time you have a different slope here, which is 4 over 2, so this is not linear. Not linear. If any of this stuff didn't really make sense, pause the video, go back, rewind, watch it now that you've kind of written all your notes, and just watch it. Otherwise, you can move on to your assignment.